Hey, Algebra 1. So here we are in Chapter 2 talking about writing equations. So our only vocabulary word is the word formula, and that's basically a rule for the relationship between certain quantities. Here we have a few quantities. E equals mc squared, where E is energy, m is mass. Let me finish writing that. And c is the speed of light. Speed of light. So you can see all of these quantities are related by this equation. So you can use formulas to see the relationship between different quantities. Our first example here has two parts, and what we're doing is translating sentences into equations. I'm going to underline the word equations to help you remember that we want something to be equal to something else. Speaking of equal signs, the word is an indicator that we're talking about two quantities that are equal to one another. Let's take a look at this example. It says 7 times a number squared is 5 times the difference of K and M. Right there, that word is lets me know that those two quantities that we're talking about on either side of the word is are equal. So let's start off with 7 times a number squared. 7, the number, let's say it's x, that's the number that's squared, so 7x squared shows us 7 times a number squared. The next part is 5 times the difference of K and M. 5 times something. So I'm going to just put that something there. When we talk about difference, we know that that is subtraction. And so we're talking about the subtraction or the difference between two values, K and M. Here is the translation of this sentence into an algebraic equation. Let's look at part B. 15 times a number subtracted from 80 is 25. There's that word is again, and that tells me that's where my equal sign is going to lie. So is 25 equals 25. All right, so now let's figure out what's on the other side. 15 times a number subtracted from 80. The wrong way to do this is to say 15, I'm doing it in pink, so you don't think it's right. 15 times a number subtract 80. That's not right. And the reason why that's not right is because it says subtracted from 80. So we need to keep all of that in mind when proceeding. So instead of doing 15x minus 80, we're going to do, I know you know it, I hear you screaming it, 80 minus 15x, where x is the number, 15 times the number. This next example is wordy, though pretty simple. Again, we're still trying to come up with an equation given some information. So here we have 50 members in the North Carolina State Senate. This is 70 fewer than the number of people in the North Carolina House of Representatives. How many people in the North Carolina House of Representatives? So let's start off with 50. 50 members in the North Carolina Senate. This is, that word this is refers to the 50. So 50 is what? 50 is 70 fewer than, fewer. I'm thinking subtraction, right? So fewer than the number of people, I guess, in the North Carolina House of Representatives. So let's let R represent that number of people in the North Carolina House of Representatives. We know that if 50 is 70 fewer, that means 50 is equal to R minus 70. And with some quick mathematical skills, we can add 70 to both sides and see that there are 120 members of the North Carolina House of Representatives. Example 3 has 2 parts, but I couldn't actually fit it the way my slides were doing some funky things when I brought it into the iPad. So we're going to just focus on the first part, leave room for the second. So we're translating, we're going to translate the sentence into a formula. This one should be familiar to you. The area of a triangle equals the product of 1/2, the length of the base, and the height. So we've got 3 things that we're multiplying. Product means multiply. Right? So in my mind, I'm thinking multiplication. Product of 1/2, the length of the base, and the height. So this looks exactly as you're probably used to, 1/2 base times height. Somebody somewhere is saying, but Dion, didn't you say that it's this instead? Doesn't this work better? Yeah, it's actually the same thing. All right, let's take a look at the next example. So part B, we have in a right triangle, the square of the hypotenuse C is equal to the sum of the squares of the measures of the legs A and B. You got to read that a couple times, but some of you may realize that we are alluding to the Pythagorean theorem. Let me draw a picture to illustrate this. The formula described refers specifically to a right-angled triangle, and that means a triangle with a right angle, and that's what that square represents. The side across from that right angle is called C, or the hypotenuse, and then the other two sides are referred to as A and B respectively. Actually, the A and B are interchangeable. And so what they're telling us here is that when you have this situation in a right triangle, the square, the square of the hypotenuse is, there's that is word again. So C squared, that's the square of the hypotenuse is. It is equal to something. What is it equal to? It's equal to the sum. We know what that word means. Add. The sum of the squares of the measures of the legs, and that's A and B. By the way, these two other sides are referred to as legs. All right, so we've got A squared plus B squared because it's the sum of the squares. And voila, we have the Pythagorean theorem. With example 4, we're going in the opposite direction. You are given an algebraic equation and you're asked to write it in terms of an English sentence. I rewrote the second one because the formatting didn't come up. That should be y to the second power. All right, so let's take a look at the first. We have 6z minus 15 is equal to 45. So is 45, I'm translating that equal sign 45 as is 45. What is 45? When I see a subtraction sign, sometimes I can use the word minus, subtracted from, or difference. Just as there are many different ways to do all kinds of things, there are many different ways to actually solve this type of a problem or to rewrite it. I'm going to do one way that I think is logical and I think is straightforward. You guys could have different answers that are also very correct. But for our intents and purposes, I'm going to start off with 45 is equal to, and let's say the difference between 6 times a number and 15. And so that is one way that we can do this. There are a number of ways that it can be done. We could have said 6 times a number, take away 15 is 45. That's right. The difference between 6 and a number, the product of 6 and a number subtracted by 15 is equal to 45. So there's a bunch of different ways, but that's just one way. Let's look at this next example. So we've got y squared plus 3x is equal to w. When I see a plus sign, I think of the word sum. So the sum of y squared and 3 times x is w is the way I'd write this out. Like I said, more than one way to do it, but this is a good way. This is our final example, example 5, and what we're asked to do is write a problem. So we're going to be given some information and we're going to write a problem. In this case, we're given that P is Beth's salary, 0.1P is the bonus, and P plus 0.1P is equal to 525. And what we have to do is come up with a sentence around this concept. Not a sentence, come up with a problem around this concept. So what I'd like you to observe here, sometimes you got to really look at it and kind of be creative because you are able to be creative, but this one doesn't really require a whole lot of creativity. That 0.1 that we have there represents 10%. I don't know if you guys remember that, but that's 10% of the bonus. 10% of the salary is equal to her bonus. So when I look at this, I can think of a really easy story. Maybe Beth got her regular salary and a 10% bonus this week. Her check this week was $525. What is her salary? So what we've done here is we've used the given information and we've used the equation. If one could solve this equation, they could answer our question. All right, so we've reached the end of our lesson, and here we are with the assignment. Please take a look at pages 78 and 80, and we'll work on these problems in class tomorrow. Thanks.